Hello everyone, this is Doc Fan. Imagine you threw a ball up, the ball goes to the peak, then the ball comes back down. What is the time of the ball in the air? It's easy to solve this question if there is no air resistance. But what if there is air resistance? How do we find the time of the ball in the air? This is a very interesting question. The way to solve this question is pretty smart, and the answer is very beautiful. Let's discuss it today. So let's say a ball is thrown upwards from ground with a velocity of v1 and falls back to ground with a velocity of v2. Air resistance cannot be neglected and it is proportional to its speed. What's the time of the ball in the air? Let's evaluate this situation. Because there is air resistance, so this is not a free fall situation. So not free fall. So the question asks for the time. So maybe we think we can use kinematic to solve this question. We know the final velocity equals to the initial velocity plus at. But the problem for this question is the acceleration is not a constant. So how do we find the acceleration? We know the acceleration equals to force divided by mass. And in order to know the force, we can do the free body diagram on the ball. Let's imagine the ball is going up. So the ball would be under two forces, gravity force going down, air resistance also resisting the motion going down. If we consider going up as a positive direction, then the net force equals to minus mg minus the air resistance. Because we know the air resistance is proportional to its speed, so we can write as the air resistance equals to k times its speed. So this equation then becomes minus mg minus kv. So then we can find our acceleration. Acceleration equals to net force divided by mass. So it equals to minus mg minus kv minus mass. Then you get minus g minus kv divided by mass. And this is your acceleration. As you can see, because the velocity is changing all the time, so the acceleration is changing all the time. You cannot solve this question very easily. If you know calculus, we know acceleration equals to dv over dt. So your acceleration dv over dt equals to minus g minus kv divided by mass. If you know how to solve an ordinary differential equation, you should be able to find your velocity as a function of time. But the issue is k is unknown. Also, the calculation is very long and tedious. So this is clearly not the way we are looking for. Alright, then how do we actually solve this question? If we think about this question, velocity equals to the initial velocity plus at. And this equation assumes the acceleration is a constant. In our case, acceleration is not a constant, so this equation doesn't help us too much. Then how about we look at the graph? If we draw the velocity versus time graph, maybe we will find out something very interesting. We know the initial velocity at t equals to 0 equals to v1. As the ball goes up to the top, its speed becomes 0. So the graph looks something like this. From the time we threw the ball up until the ball reaches the peak, the time it used, we call it t1. We know for the velocity versus time graph, this area here is the displacement. Now, let's look at the second half of the motion when the ball is falling. The ball starts from 0 velocity at the peak, which is right here. Then, as the ball goes down, the ball finally reached the velocity of v2. So the graph looks something like this. And the time from the peak to the ground, let's call it t2. And this is the displacement for the falling motion. We do realize there is a hidden information, that is, the displacement going up and the displacement going down. They have the same magnitude and they have the opposite direction. What does this mean? That means the area here and the area here, they have the same area. The sign is opposite. So how this graph is going to help us to solve this question? We know the air resistance equals to a constant times velocity. So if velocity versus time chart looks like this, what if we times a constant k to this graph? This graph, the skew might change, but the area under both segments of motion is going to be the same. So basically, we can consider this graph is the air resistance force as a function of t. And what does this mean? We know that if we have a force versus time graph, the area under the force and the time graph, that is our impulse. So basically, what we learned here is the impulse going up and the impulse going down. They have the same magnitude, but they have opposite sign. As a result, the total impulse of air resistance would become J up plus J down. That would be 0. This basically tells us the total impulse from air resistance during the whole motion is 0. This gives us an idea. What if we use the impulse momentum theory? So the impulse equals to the change of momentum, and the change of momentum equals to dart mv, which is mass times final velocity minus mass times initial velocity. And in this case, because the total impulse from air resistance is 0, so the only impulse is coming from gravity. And the impulse from gravity equals to F times delta t. And the gravity doesn't change, so gravity is minus mg. And the time is t1 plus t2. Let's just use t to represent that. So the upward time is t1, the downward time is t2. We just consider the total time because gravity is a constant. So the total impulse during this whole motion only comes from the impulse of gravity, which equals to minus mg times t. And then what is our final velocity? Our final velocity is v2 going down. So it's mass times minus v2. And what is our initial velocity? It's v1 going up. So it's positive. Then minus mv1. So if we simplify this, we have minus m times v1 plus v2. Then our total time equals to v1 plus v2 divided by g. So the correct answer is A, which is very beautiful. We might think the real answer would be very complicated because air resistance exists. But the impulse due to air resistance going up and going down actually cancels each other. So the final answer is very simple. For this question, we actually use graph to find the impulse, which is very nice. Hope you like today's discussion. Follow me for more interesting physics questions. Thank you.